All right, so for this video, I'm going to take you through a few of the problems for the 18-4, how good is your aim? So I have this chart right here. So I'm going to kind of pull it as it goes. So what we start with is time. Time is, what it's saying is in 0.1 seconds, how far did the bullet travel and how much did it drop due to gravity? Now we have a few givens that are in the problem. And for this one, our velocity is going to be 500 feet per second. I'll put that here. And gravity is a constant, so that's going to be 32 feet per second squared. Okay. Those are given to us. Gravity is always constant, and velocity is going to be 500 for this problem. So what it asks you is, in 0.1 seconds, what's the distance in travel? Now, I know on your chart, it gives you t squared. We're going to leave that out for right now. Okay. So distance traveled, what we're going to do is time is going to be 0.1. That's going to equal distance over velocity, which is going to be 500 feet per second squared. Okay, so we do 0.1 equals d over 500 feet per second squared. We have to get d by itself. So we're going to multiply both sides by 500. That will cross out this side. Multiply that by 500. That's going to be feet per second squared. All right, come on, camera. Focus up. There we go. All right, so I'm going to move my camera a little bit. So 500 times 0.1, that's going to give you 50 feet. Okay. Then we're going to look for distance dropped. So we have d equals 1/2. Gravity is constant. That's going to be 32 feet per second squared. We're going to multiply that by t squared. Our t is 0.1. We're going to make sure we square that. Okay. So here we have d equals 1/2, 32 feet per second squared. That's gravity, that's given. And then in 0.1 seconds squared. And when you do that math, and you put it all out, you get 0.16 feet when you calculate it all out. Now it asks you for inches up here. So since it's in inches, we're going to do 0.16 feet times. There's 12 inches in 1 foot. Those feet cross out. And you get an answer of 1.92 inches. So for that first one, in 0.1 seconds, the bullet would have traveled. There we go. The bullet would have traveled 50 feet, and it would have dropped 1.92 inches. The second one, we do 0.2 seconds. 0.2 seconds, how many feet does it travel? Once again, 0.2 equals d over, our velocity is going to be is going to stay the same. That's the speed at which the bullet is traveling. So when we calculate this out, we multiply both sides by 500. We should get d equals 100 feet. Right now we do d equals 1/2. Gravity is going to be the same. And we're going to multiply that by 0.2 squared, which is going to be 0.04. And remember, I left out that column just to make it a little more simpler for us. So when we calculate this out, we get d is equal to 0.64 feet. If we do 0.2 squared, that's going to be 0.04. Multiply that by 32, and then essentially divide that by 2. We're going to take 0.64 times 12 inches, because this is in feet. There's 12 inches in a foot, so the feet cross out, and we're left with 7.68 inches. So in 0.2 seconds of firing that bullet, the bullet would have traveled 100 feet, and it would have dropped 7.68 inches. Okay. And then we carry that through to the bottom with 0.6 seconds.